My name is Jaime Martí. I am a researcher in a public university in Ecuador. I have been working with digesters and anaerobic digestion for the last 20 years. And I want to share with you some experience we have had in the Andean countries like Bolivia or Ecuador. The first thing I want to show you some pictures from where I come from. This is the jungle in Ecuador. To see where is Ecuador is this small country that you will find between Colombia and Peru. Ecuador is divided in three zones. You can see the coast in the east, the mountains that cross all the country, and they are reach over 6,000 meters above sea level. And on the west, on the east, you have the Amazonia. There is where our university is placed. You can see here even the volcanoes, these white spots on the left. And the university is just in the middle of the jungle. You can see in this picture. The name of the university is Universidad Regional Amazónica, IQAM. One of the main things of the university is that is focused on sustainability and biodiversity. And also we are surrounded by indigenous Quechua people. So that means that a lot of the projects we do, a lot of the research projects are focused in resolving problems that are for the problems from this kind of people, the Quechua people. So now I can present myself. You can see that this was my first digester. It was almost 20 years ago. It was at 10 meters above sea level. It was in Canary Islands. Later I began to work in Bolivia at over the 2,000 meters above sea level, doing digesters with Quechua people in the valleys. And later I moved to the highlands of Bolivia with the Aymara people, doing digesters over 4,000 meters above sea level. And in these places you can reach minus 13 degrees during the winter nights. The highest digester I have made is over 5,000 meters. It is a wastewater treatment plant in a hut where you go after you try to climb this mountain, and I will talk about this later. So my experience is about low-cost digesters. That means that these digesters, they don't use any heating or mixing devices. So the most famous one are the Chinese model or fixed dam model. You will find a lot of these kind of digesters in Asia and Africa, but in Latin America the most famous digester is the tubular digester. Usually these kind of digesters are fed with animal manure from farms. We use the biogas that is produced for cooking or for heating baby pigs that you can see in these videos. Also, you can run a small machine in a farm to cut grass or to run a small pump or what else you need, but in small machines. Usually it's said, if you look for in the academia and the literature, that anaerobic digestion needs to be heated, needs to work at 35 degrees, but this is not true. Usually in Europe and in the United States, most of the digesters are heated, but in the rest of the world, they are not heated. Usually you can find some literature where they have been trying how is the performance of the anaerobic digestion at temperature lower than 20 degrees. And what they report is that the amount of biogas you are producing is very, very low. For example, in this paper, they are saying that at 15 degrees, you are going to get something around 50 liters of biogas per kilogram of organic matter, when the reference at 36 degrees is more than 300 liters of biogas per kilogram of organic matter. But what happens when we go to a real world and we measure how much biogas is producing the digesters that are working at that temperature? Here I show you the results of a digester that was 8 years old. It was in Colombia. It was fed with pig manure and was producing nearly 400 liters per kilogram of organic matter. So that means that is even better than the temperature, than the biogas that you would get when you are working at 36 degrees. You have to see that this digester was even at only at 17 degrees working. What is the situation? Why this digester is producing more biogas than expected is because the microorganisms are adapted to this condition, are adapted to these temperature conditions. So temperature is important, but we can use microorganisms that can be adapted to these temperatures, to low temperatures. Just in the last year, in 2022, this paper was published where they talk that it's not only about mesophilic or psychrophilic microorganisms. We have to talk about also about psychotrophic microorganisms, that these are working at temperatures nearly 20 degrees. So this can explain why we have so good results when we work at low temperatures. What happened in the laboratory is that usually they are not measuring how much biogas you are producing when you are in low temperatures. They are measuring how is the thermal shock that the microorganisms are suffering at low temperatures if they become from high temperatures. There are some papers also that talk that you can have anaerobic digestion even at 4 degrees. So I share with you also this paper. So now I'm going to show you some experience in Bolivia. Bolivia is this big country in the middle of Latin America. The country 60% is Amazonia, but I'm going to talk about experience in the highlands. These highlands are usually around 4,000 meters above sea level. First of all, I want to talk about an experiment we have been made in nearly the Lake Titicaca, nearly La Paz. This is the places where, this is the highlands of Bolivia. It's a very flat place, but very cold during the nights and also during the winter. It is almost over 4,000 meters above sea level. The population is rural people who belongs to the Aymara indigenous nation. They have a lot of lack of infrastructure. There is a lot of poor people there. So we began doing some digesters to treat manure from animal farms. You can see here a digester is just inside this greenhouse. The greenhouse is made with a plastic greenhouse. And we used to put insulation in the trench. This insulation at the beginning was with a straw, but after 2 years we see that this straw was lost, so no insulation. We decided to try to improve this kind of technology. We had also some problems with the cover of the greenhouse, because if it gets damaged after 2 or 3 years because the sun and the climate conditions. We have been working with the public university of La Paz. In these conditions we built 10 digesters as these ones that you can see in the picture. We were trying different things, different ways to fit these digesters and different experiments. We were measuring all these digesters, how much biogas they were producing, also thermal performance of the digesters. And one thing we learned is that, for example, you can put soda bottles inside the digester and you will increase 50% the amount of biogas produced. Why? This is because the microorganisms, they need to be attached to a surface. So if we put these bottles, plastic bottles cutted inside the digester, we will have more space for the microorganisms to be colonized. So when we talk about soda bottles, we talk about this kind of bottles, normal ones you can find in any wasteland. And this is a picture, for example, from the greenhouse, the problems that we get because of the time and the high solar radiation. So we move forward to change some components of this kind of digesters that were working at cold climate conditions. We changed the cover. We never use more greenhouse plastic. We changed by polycarbonate solid cover, and we changed the insulation by this kind of polyethylene insulation. Also, the reactor is all the time black color to gain heat from the solar radiation. With these conditions, we can get above 8 or even 10 degrees inside the digester over the mean ambient temperature of the place. So here you can see some pictures inside the greenhouse, the new greenhouse. We have been trying to improve this greenhouse to make it more easily to build. We tried this thing also there in La Paz to take out these adobe walls, but we have some problems. For example, we reach too much heat inside the greenhouse, so we melt the plastic of the reactor. So there is a limit when you try to heat a digester. You cannot heat as much as you want. You have to consider the limit of the materials. You can see here in this picture how the plastic is melted because of the temperature we reach inside the greenhouse. This means around 70 degrees. We have been measuring and publishing a lot of research on the thermal performance of this kind of digesters, and we see that it's easy to work in places where even during the night you reach -5, -6 degrees when you are considering black color for the reactor, insulation for the trench, and a greenhouse to protect and to conserve all the heat. Also, I want to show you some experiments we continue doing with trying to improve this greenhouse, to simplify it. This is in Ecuador. This is the Cotopaxi volcano. We made a small digester there. Here you can see the process. We were using, here you can see the trench and how we expected to build a new greenhouse here. Very easy to do. Here you have the greenhouse, later the insulation, and later the digester. When you build the digester, you have to fill it of air, and you put in the trench, and later you begin to cover it with this greenhouse. So this is at the end how it looks. We were trying to measure the thermal performance or also the biogas production of this digester, but we had problems with the volcano that is very near because this volcano began to the eruption of this volcano. So here you have a small video. So from the first day that this volcano was beginning the eruption. So we were not allowed to go to this site because it was too much risk. More experiences, for example, in the south of Bolivia, very near to the frontier to Chile, near to the Red Lake is the name in English. In Spanish should be something like Laguna Colorada. We were asked to build a wastewater treatment plant for 80 people. So we went there and we do what we know to do, that is to build a greenhouse. This place is over 4,300 meters above sea level. This is the placement where we have been working. The area is very, very dry. It's like a desert, but sometimes you can reach even minus 20 degrees during the night and get very white because the snow fell to the ground. So what we did is to propose a big greenhouse covered with a polycarbonate roof. Inside the greenhouse you can find these digesters. There are 9 cubic meters digesters each one. The insulation is 20 centimeters wide, and inside each digester we put 300 bottles of plastic bottles to increase the surface that the microorganisms can colonize. We separate grey water from black water, so the black water from the toilets went directly to these 2 digesters, and later it joins with the grey water. It's mixed with the grey water and they go to a 3rd digester together. And from here we go to a small wetland also covered, where you can take out all the last nutrients that you will find in the effluent of the digesters. We have also some problems with temperature. We reach again over 70 degrees. You can see how the PVC pipe was melted, so you have to be very careful with the amount of energy you want. And the last situation is this one in this mountain. This is Huayna Potosí. This is the highest wastewater treatment plant that I think is in the world. It is over 5,000 meters above sea level. This mountain, the top of the mountain is 6,088 meters, and at the middle you have a hut where you sleep. The day before you have to go to, you want to climb to the top. So we were asked to build a wastewater treatment plant. Before, what they had is a honey bucket place, but they were not taking the black plastic to any place. They just were throwing out the way. So what we propose is to build new toilets with digesters and also a wetland. Here you can see the place is with a lot of stones, so it's not easy to work there. Later I'm going to show you the toilets, but here is where the toilets were placed. Here are the digesters, and at the end the wetlands. The digesters, like the idea was to build something very similar to a solar cooking box. So instead of cooking food, we were cooking other type of things. We make these digesters using typical water tanks that you can find in any place, in any country. And what you can see here in these pictures, the 3 first tanks receive the black water, and just the last tank receive the grey water. So this is how it was working. This system is still working, so it's more or less 10 years ago. They are happy with it. We have no data about this system. What we know is that they have no smelling. The people that manage this hut, they are happy. So here are some pictures of water per time that you use the toilet. It is a great idea, just using things that you can buy also in any shop, in any country. This could be applied to any toilet, existing toilet. And the good thing is that if you reduce the amount of water that is being used for the toilet, you will also reduce the volume you need for the digester. So we made a small digester for these kind of toilets. We use also, again, materials that you will find in any shop. This is a small digester. Also, we divide the digester in 2 chambers, one of them full of bottles, of soda bottles, and we install this digester. So with a very small volume, this was 500 liters, you can solve the problem when you are using just 1 liter of water per time you go to the toilet. So just the end, this is a simulation of the thermal performance of a digester, for example, here in Sisimiut. This is what you can find here. The blue line is the thermal performance when you are using black color, insulation, and greenhouse. And what we see is that it's gonna get frozen during the harder part of the winter, and the digester is going to be working only during 6 months per year. Just to finish, conclusions: we can adapt microorganisms to cold climate conditions. If you work with the digester in cold climate conditions during the first 12 months, the microorganisms will be adapted to these conditions, but you can also use microorganisms, native microorganisms that are already in the lakes here, for example in Greenland, and put them inside the digester. You just need to do this thing once, because after this they will colonize all the digesters. So you can take from any pond inside the city this kind of microorganism. You can use solar radiation as heating source. You can use soda bottles to increase the surface. You have to accept in these conditions that the digester is going to get frozen almost for 4 months per year. So you need to think how to store the manure for these 4 months after you will put them inside the digester. That is. Thank you very much.